Today we are going to learn about understanding and applying fairness metrics in AI. You will learn how to assess and improve AI models using common fairness metrics, gaining skills in implementing these metrics and identifying biases. Welcome to our video on understanding and applying fairness metrics in AI. In today's digital age, artificial intelligence plays a pivotal role in decision-making processes. However, without proper checks and balances, AI systems can perpetuate existing biases and discrimination. Fairness in AI ensures that models are ethical, unbiased, and compliant with regulatory standards. In this video, we will explore the significance of fairness metrics, understand how to choose the right ones for your AI models, and learn how to implement them effectively. By the end, you'll be equipped to assess and improve AI systems with confidence.
Fairness metrics are quantitative measures that help evaluate the level of bias or fairness in an AI system. These metrics are crucial as they provide a structured way to assess whether the decisions made by AI models are equitable across different demographic groups. There are various types of fairness metrics, each serving a unique purpose in evaluating model performance. For instance, some metrics focus on equalizing outcomes between groups, while others assess the probability of a favorable outcome for individuals. Understanding these metrics is essential to identify potential disparities and ensure that AI systems do not unfairly disadvantage any particular group.
Demographic parity is a fairness metric that ensures equal treatment across different demographic groups by requiring that each group receives positive outcomes at the same rate. It is a popular metric because it provides a straightforward way to assess fairness. However, it is not without limitations. For example, achieving demographic parity might not always be possible or desirable if the base rates of positive outcomes differ across groups for legitimate reasons. Nonetheless, it remains a useful tool in many contexts, such as hiring algorithms or loan approvals, where equal opportunity is a legal and ethical requirement.
Equal opportunity is another crucial fairness metric that emphasizes the need to equalize the true positive rates between different groups. Unlike demographic parity, which focuses on overall positive outcomes, equal opportunity ensures that individuals who qualify for a positive outcome are equally likely to receive it, regardless of their group membership. This metric is particularly useful in scenarios where false negatives have severe consequences, such as in healthcare or criminal justice. While it provides a more nuanced view of fairness, implementing equal opportunity can be challenging due to the complexity of balancing true positive rates across groups. Choosing the right fairness metric for your AI model is a critical decision that depends on various factors. First, it's important to understand the context in which the model operates and the goals you aim to achieve. Some metrics may be more appropriate in certain settings than others. Additionally, balancing multiple metrics can provide a more comprehensive view of fairness. Stakeholder requirements and ethical considerations also play a significant role in this decision-making process. By carefully evaluating these factors, you can select the fairness metric that best aligns with your model's objectives and ethical standards. Implementing fairness metrics in Python can be a straightforward process with the right tools and knowledge. Python offers a range of libraries, such as fairness indicators and A360, that provide pre-built functions for assessing and mitigating bias in AI models. In this section, we'll walk through a step-by-step guide on how to use these libraries to evaluate your model's fairness. We'll also provide example code snippets to illustrate the process, covering everything from data preparation to testing and validation. By following best practices, you can ensure that your AI models are not only accurate but also fair and ethical.
To illustrate the practical application of fairness metrics, let's delve into a real-world case study. In this example, we'll examine an AI system used for hiring decisions at a tech company. Initially, the model demonstrated a bias against certain demographic groups, leading to unfair hiring practices. By applying fairness metrics, such as demographic parity and equal opportunity, the company was able to identify and quantify the bias present in their model. The results revealed significant disparities in positive outcomes across groups, prompting the company to implement strategies to rectify these issues. This case study highlights the importance of fairness metrics in real-world applications and the positive impact they can have on organizational practices. Once bias is identified in an AI model, the next step is to implement strategies to mitigate it and improve model fairness. There are several techniques to achieve this, categorized into pre-processing, in-processing, and post-processing methods. Pre-processing involves modifying the input data to remove bias, while in-processing adjusts the model parameters during training to promote fairness. Post-processing, on the other hand, alters the model's outputs to ensure equitable outcomes. Continuous monitoring is also essential to track the model's performance over time and make necessary adjustments. By employing these strategies, organizations can enhance the fairness of their AI systems and minimize the risk of discrimination.
While fairness metrics are valuable tools, they are not without challenges and limitations. The complexity of fairness in AI arises from the need to balance multiple, often conflicting, objectives. Existing metrics may not capture all aspects of fairness, and applying them can sometimes lead to unintended consequences. Additionally, achieving a balance between accuracy and fairness can be difficult, as improving one may compromise the other. The challenges extend beyond technical considerations, requiring interdisciplinary collaboration between fields such as law, ethics, and social sciences. Ongoing research is essential to develop more comprehensive metrics and address these limitations effectively. As AI continues to evolve, so too do the trends in fairness metrics and ethics. Emerging trends focus on developing more sophisticated and comprehensive metrics that better capture the nuances of fairness. Innovations in this area are likely to involve the use of advanced machine learning techniques and the integration of fairness metrics with broader AI ethics frameworks. Policymakers also play a crucial role in shaping the future of AI fairness by establishing regulations and guidelines that ensure ethical practices. Looking ahead, the challenges and opportunities in this field are vast, offering exciting possibilities for creating more equitable and just AI systems. In conclusion, understanding and applying fairness metrics in AI is essential to ensure that models are equitable and ethical. We've explored the significance of fairness in AI, delved into common metrics like demographic parity and equal opportunity, and discussed strategies for implementing these metrics effectively. While challenges exist, the future of AI fairness holds great promise, with ongoing research and innovation paving the way for more just and inclusive systems. We encourage you to continue learning and applying these principles, contributing to the development of fair and responsible AI technologies.